This newly identified entity, quickly dubbed 3I, Atlas, was racing at an astonishing near speed of 60 km per second, faster than any known object within our solar system at that distance from the Sun. But the speed was only the beginning of the story. When data began pouring in, scientists around the globe were astounded. The object was ejecting pure nickel at an astonishing rate, exceeding 10 pounds per second. This wasn't nickel alloyed with other metals or blended with dust, but nickel in its most elemental form. In nature, nickel is usually found alongside iron in asteroids and comets, making this occurrence entirely foreign to existing scientific understanding. Questions began radiating from observatories. Could nature possibly create such an anomaly independently? Or was this evidence of something engineered rather than born? Research teams across 3 continents swiftly mobilized to collect further data. In reviewing archival footage from the Zwicky transient facility dating back to weeks before, astronomers found faint streaks of 3I, Atlas between June 14 and June 25. During that time, automated systems had previously dismissed these faint trails as mere background interference. Only after the detection on July 1 did they fully comprehend that 3I, Atlas had quietly been active for weeks, concealing itself in plain sight. Meanwhile, NASA's exoplanet hunting satellite had already captured images of the same region when the object was still situated far past Jupiter, nearly 6 astronomical units from the Sun. At that distance, most comets are dormant and completely inactive. However, 3I, Atlas exhibited a distinct tail, outgassing when solar heat should have been far too weak to instigate any activity. This was not merely an oddity. It posed a serious challenge to our understanding of the behaviors of comets and interstellar bodies. Additional inquiry using the Very Large Telescope in Chile added to the enigma. Astronomers directed their instruments toward the object's coma, anticipating the usual mixture of water vapor, dust, and trace metals. To their surprise, what they found was unprecedented: atomic nickel, abundant and streaming freely into space. Iron, typically found in natural materials alongside nickel, was absent. On Earth, such separation demands intense energy and large-scale refinement processes. Yet here, it appeared to happen naturally amidst the void of interstellar space. Then, data from the James Webb Space Telescope intensified the peculiarity. Its infrared instruments unveiled an extraordinarily high carbon dioxide to water vapor ratio, potentially as high as 80:1. Common comets are predominantly composed of water when they heat up near the Sun. Instead, this object operated under a chemistry that seemed to follow an entirely different set of rules. Adina Feinstein, one of the first scientists to share findings on 3I, Atlas, emphasized that this object wasn't simply a curiosity. It necessitated a complete re-evaluation of how such bodies form and evolve during quiet voyages through interstellar space. Naturally, theories started to emerge. Harvard astrophysicist Avi Loeb proposed that the selective nickel outgassing could point to a technosignature, an indication of artificial construction. He maintained that such purity and precision didn't occur in nature without some form of intervention. From his perspective, the suggestion that 3I, Atlas was a probe, possibly even self-replicating, was no longer fringe speculation but a credible hypothesis needing rigorous exploration. Conversely, NASA remained cautious. The agency publicly emphasized relying on data while avoiding dramatic claims. However, internally, analysts acknowledged that dismissing even the faintest chance of an engineered origin might overlook one of humanity's most monumental discoveries. Time was against them. By December 2025, the object would vanish behind the Sun, becoming nearly impossible to track until its eventual re-emergence months later. This created a narrow window for astronomers to gather essential information. Major telescopes, both terrestrial and orbital, focused their attention on this enigmatic object. Spectra were analyzed, trajectories calculated, and images taken across all possible wavelengths. Scientists recognized that every photon counted. Each small piece of data could offer crucial insights into one of the greatest cosmic mysteries of our time. The parallels to past interstellar visitors emphasized the exceptional nature of this discovery. Oumuamua, detected in 2017, left astronomers baffled due to its strange acceleration and elongated form. Borisov, visible in 2019, became the first confirmed interstellar comet, pristine and icy. However, 3I, Atlas offered something entirely different. Its remarkable chemical selectivity, improbable orbital path, and rapid velocity distinguished it from everything previously encountered. In the brief span of a decade, 3 confirmed interstellar objects had traversed our solar system, yet this one seemed to defy nature's fundamental laws. Regardless of its true identity, one fact was clear. 3I, Atlas profoundly impacted the field of astronomy, proving that the universe continues to present surprises that can challenge our core beliefs. Whether it ultimately turns out to be a natural oddity that transcends existing comprehension or the first. Some discoveries in astronomy arrive like whispers, subtle signals buried in data that only the most patient eyes can catch. Others arrive like thunder, shaking the very foundations of what we think we know about the universe. The interstellar visitor known as 3I, Atlas was one of those thunderclaps. It didn't just drift into our solar system like the handful of objects spotted before it. Instead, it made an entrance so strange, so improbable, that even the most cautious scientists couldn't help but admit they were facing something unprecedented. Within less than a decade, humanity had confirmed 3 separate interstellar objects crossing into our cosmic neighborhood. But Atlas was different. Neither its speed nor its size alone explained the shock it brought. What set it apart was the way it behaved, the way it seemed to ignore natural law at every turn. Telescopes around the world locked on as teams coordinated tirelessly with orbiting platforms, timing their observations with painstaking precision. Every passing day revealed new details, often hidden in plain sight. Archival images taken weeks earlier, initially dismissed as nothing unusual, were now re-examined. Subtle outgassing, delicate hints of a tail, and traces of activity stretched the timeline of Atlas further back. It became clear that this object had been active for months, perhaps even longer, before it was ever detected. That in itself was unsettling. Comets and asteroids usually tell their stories with predictable signatures: frozen gases evaporating under solar heat, familiar chemical fingerprints that match models built over centuries. Atlas refused to play by those rules. Chemical analysis revealed something baffling. Nickel was escaping from its surface, but in ways that standard models could not explain. Even stranger, the expected presence of iron was nowhere to be found. Carbon dioxide appeared in unusual ratios, hinting at processes that planetary science had never accounted for. Researchers tried to build models, running simulations over and over. Each one failed. No combination of interstellar travel mechanics or comet formation theories could reproduce what was being observed. Every hypothesis ended with contradictions. The object wasn't just unusual, it was defying explanation itself. That's when speculation took center stage. Could Atlas be a fragment flung out of a dying star, a piece of a supernova traveling through interstellar space for eons until fate drew it near our Sun? Or was it something even stranger, a naturally evolved probe of sorts, sculpted by cosmic forces we barely understand? And then came the question no one could avoid: was this something designed? An artifact built with purpose, drifting across the void as a message, a machine, or perhaps a relic of a civilization far older than ours? Scientists tread carefully, but the debate was fierce. Inside observatories and research centers, discussions lit up around the clock. Analysts double-checked every calculation, knowing one error could unravel the entire picture. Emails, late-night video calls, and chat threads swirled with arguments over probability, orbital mechanics, and chemical signatures. Every new dataset seemed to bring both answers and fresh riddles. Beyond the scientific community, the public was captivated. Headlines speculated on alien technology while official press releases tried to balance fascination with caution. For every person dreaming of a discovery that might confirm we aren't alone in the universe, there were scientists reminding everyone that extraordinary claims demand extraordinary evidence. Yet, the very improbability of what Atlas was doing kept imaginations alive everywhere, from classrooms to conference halls. Its orbit was retrograde, meaning it moved against the grain of most celestial traffic in our solar system. It wasn't just grazing planets, it was threading a path through sequential flybys with eerie precision. Combine that with its chemical oddities, and the picture became even more unsettling. Analysts ran simulations countless times, tweaking inputs, correcting margins of error. The outcome never changed. Atlas was either the most extraordinary natural coincidence ever recorded, or something else entirely. As 2025 drew to a close, anticipation reached a fever pitch. Astronomers knew they were on the edge of a historic moment, whether Atlas proved to be a bizarre natural phenomenon or the first tangible sign of interstellar technology. Either way, the implications were staggering. A natural anomaly would force humanity to rewrite its understanding of planetary science. An engineered artifact would mean we're not alone, and perhaps never were. For now, though, the mystery remains. Every observation adds a piece to the puzzle, but the full picture refuses to emerge. The outgassing processes remain unexplained, the chemical ratios still defy known models, and the trajectory itself whispers of possibilities our current science struggles to grasp. What is clear is that Atlas has already reshaped astronomy, expanding the boundaries of what we consider possible. The countdown has begun. Soon the final window for direct observation will close, and we will be left only with the data captured, archived, and studied for decades to come.